I'm Anil Kumar sharing with you applications of derivatives. We'll discuss rate of change with the help of 4 related questions. Let me thank all the subscribers and viewers who have contributed for providing me with these questions, and some of you who have really waited for a couple of weeks to get the solution. Question number 1 here is, the diagram represents an empty vessel in the shape of a right circular cone of semi-vertical angle 45 degrees. Water is poured into the vessel at the rate of 10 centimeter cube per second. Find the rate at which water level is rising after 5 seconds. Well, the diagram, let me just make one here. Let me make a smaller one. Then we'll discuss and solve it later, right? So basically, in all these questions, I've taken circular cone with slight variations. So the first one gives us the angle, and that is 45 degrees. Second question here is, water is poured into an inverted right circular cone at the rate of pi meter cube per minute. The height and the diameter of the base of the cone are both 12 meters. How fast is the water level rising when its depth is 2/3 of the height? Okay. Question number 3 is, metal shavings are being emptied into a conical pile whose height is same as the diameter. If the shavings are spilled onto the pile at the rate of 10 centimeter cube per second, how fast is the radius of the pile increasing when the height is 5 centimeters? And question number 4 is, a conical reservoir is filling with water at a constant rate of 3 meter cube per minute. The reservoir is 3 meter deep and has a maximum diameter of 8 meters. Determine the rate at which depth of the water is increasing when the depth is 2 meters. So what you notice here is we're talking about a similar drawing, a right circular cone, in which we're giving you ratio between height and the diameter or the radius. We also provided you with the rate at which it is being filled, that is rate of change of volume. You need to find rate of change of height or rate of change of radius. So that's the question. You can always pause the video, copy these questions, solve them, and then look into my solutions. So now I'll take them one by one. Question number 1. The diagram represents an empty vessel. So let me sketch the diagram first, right? So let's say this is the empty vessel. We're talking about a cone, right? So that's how it is. So diagram represents an empty vessel in the shape of a right circular cone of semi-vertical angle of 45 degrees. Semi-vertical means if I draw this line vertically, then the angle here is 45 degrees. That is what it means, right? So this angle is also 45 degrees. Water is poured into the vessel at the rate of 10 centimeter cube per second. That means dV dt, rate of change of volume, is 10 centimeter cube per second. Find the rate at which water level is rising after 5 seconds. So we have to find rate at which water level is rising, let's say height, with time, when time is equals to 5 seconds, right? So this is what we need to find. Now, as you can see here, we are given volume of 10 centimeter per cube. That means at any instant of time, from here you can say at time t, what is the volume? Volume is equals to 10 times t, right? So that is the relation between volume and time, where time is in seconds. Perfect. Now we also know that volume of a cone is equal to 1 by 3 pi r square h, where h is the height and r is the radius, right, at any particular instance of time. So let us say that, let's say it is filled up to this place, right? So in that case, what we will say is that, let's say this is the radius r, and that is the height. Then the volume of water contained will be 1/3 pi r square h. You get an idea, right? Since it is being filled at 10 centimeter cube per second, the volume is also 10 times t, the time. Now, the angle of 45 tells you that ratio of r and h is what? 1, right? So when we say 45, we can also say that tan of 45 degrees is r over h. And we know tan of 45 degrees is 1. So we also know that radius is equals to height. So from the question, we have all these things known to us. Standard formula, 1/3 pi r square h. And the given conditions tell you that radius is equals to height and volume is equals to 1/3 pi r square h, where volume is 10t. Since we need to find height, rate of change with time, what we can do, at t equals to 5 seconds, we can find what height it should be, right? So at t equals to 5 seconds, what we know is r is equals to height. Let's find height. So we have this relation 10t equals to 1/3 pi. Let's replace r with h. So we get h squared times h. So if I substitute t as 5, I can write what h is, right? So, and rearrange, right? So what we get here is 10 times 5 equals to 1/3 pi h cubed. And from here, we can write 3 times 10 times 5 divided by pi equals to h cubed, right? So height h is equals to cube root of all this, right? 150 over pi, right? So that is the height at t equals to 5. So let's calculate this height. So we'll do 150 divided by pi, which is 47.74. And if I do cube root of this, we get, so let's do cube root of 150 divided by pi, bracket close, equals to 3.62. So what we get here is height equals to 3.62783. Let me write like this. Okay, and the units given to us are in centimeters. Okay. The expression for volume in terms of height can be written as 1/3 pi r equals to h, right? So h cubed. Right. Since r equals to h, we can substitute and find this relation. Is it okay? Now what we know is the relation between volume and height. We need to find rate of change of height. So let's find derivative with respect to time on both the sides. So we are finding, or we are differentiating with respect to time on both the sides. So we get dv dt equals to 1/3 of pi 3h square dh dt, correct? Now from here you can isolate dh dt. So dh dt is equal to, we'll cancel this 3 and 3, simplify it a bit. Okay. So it becomes 1/pi h square dv dt, correct? Since we want to find the height when t equals to 5, we know at that time height is 3.6278. So dh dt at t equals to 5 is equal to, let's substitute, right? dv dt is 10. So we have 1 over pi 3.6278 whole square times 10. That is the answer. So we already have this number here, right? So let's square this number. So if I do, or let's redo it. So we'll do 10 divided by, within brackets, pi, within brackets, 3.6278 whole square. Just close the bracket, right? So all this is denominator equals to, we get our answer as 0.24 round to 2. So we get the rate of change of height as 0.24 centimeters per second, right? So that becomes the answer. So I hope the steps are absolutely clear. So the idea is first to relate volume with time, which is volume is 10T. We know the standard formula of cone. Volume is 1 by 3 pi r square h. We can replace h with r since we know the angle is 45 degrees. Tan 45 is 1. So the ratio of radius and height is 1:1. Once we get explicitly formula in terms of height, we can find derivative with respect to time on both the sides and calculate rate of change of height with time for t equals to 5 seconds. So I hope the steps are absolutely clear. Let's move on and take up question number 2. Question number 2. Water is poured into an inverted right circular cone at the rate of pi meter cube per minute. The height and the diameter of the base of the cone are both 12 meters. How fast is water level rising when the depth is 2/3 of the height? Right. So let us sketch the diagram. It helps. Now, since we have already done an example, I think the concepts are absolutely clear. In this particular case, we are given both height and diameter of 12, right? So that is what we are given, 12 meters. Okay. Now at any instance of time, let's say this is the water level. We can find the relation between height and the radius. That is very critical, right? Now in this particular case, whenever we are talking about a cone, we know volume is 1/3 pi r square h. Now since the ratio of diameter and height is same, we know diameter is twice radius, right? So the ratio of diameter over height is 1. So that really means that height is equals to diameter, or height is equals to 2 times radius. Now in this particular question, as you see, how fast is water level rising when depth is 2/3? That means we should write r in terms of height, right? So r is equals to half of height. So in this particular formula, we'll replace r with half of height. So we get volume equals to 1/3 pi half h whole square h. So that gives you the volume formula as 1. So this is 4, right? 4 times 3 is 12 pi h cube. So that becomes the formula. So first step should be to derive the formula in one variable, right? So what we have got here is volume with respect to height as a function of height, and it is pi over 12 h cube. Does it make sense to you? Now we know that dV dt, rate of change of volume, is equals to pi meter cube per minute. And we need to find how fast is water level rising when the depth is 2/3 of height. So the depth, that means, is 2/3 of height. That means 2/3 of height of 12. That is what it means, right? So 2/3 of height will be 24 divided by 3, which is 8 meters. So we are looking for height of 8 meters for the water level. So when height is equals to 8 meters, the radius will be 4 meters, correct? It is half. That's the ratio. Right. So that is the situation. So now we can find what rate of change of volume and height is with respect to time. So that means differentiate with respect to time. So we get dV dt equals to pi by 12 times 3 h square dh dt. Correct? Isolate dh dt. So we get dh dt is equal to, well, this can be simplified. We could write this as 4. Okay. So it becomes 4 over pi h square dV dt. Correct? So that is how we could actually isolate this and get our solution. We need to find rate of change of height. So we can always substitute h equals to 8, dV dt as pi, and calculate. So we know rate of change of height with time when height is equals to 8 meters is equals to 4 over pi times 8 square times dV dt is pi. So you could appreciate why pi is given, it cancels. So we kind of get exact answer. Is it okay? So we get an answer which is 4 over 64, 8 times 8, or 1 over 4 times 1, 24, 6, 1 over 16. And the units are, height is in meters per minute, right? So we can get our answer is that the rate of change of height, that is dH dt, when height is equals to 8 meters is equal to, we could write in decimals, let's do it. 1 divided by 16 equals to 0.0625 meters per minute. Right? So there is no harm in also writing in fractions. So I hope the concept is clear. So that is how you could find rate of change of height when the height is 2/3 of its maximum height. Now let's take up the third example. Question number 3, which is exactly on the same lines as we did previous 2. Metal shavings are being emptied into a conical pile whose height is same as diameter. So we're given height equals to diameter, which is 2 times radius. If the shavings are spilled onto the pile at the rate of, so we know rate means volume, right? dV dt is 10 centimeter cube per second. How fast is the radius of the pile increasing? So we need to find what is dr dt when the height equals to 5 centimeters. Right? So I think the situation is absolutely clear. That is the question. I'm not even sketching this time. You know what we are going to do. So first step is write down the formula of volume, which is 1 by 3 pi r square h. You need to find dr dt, right? So we need to find volume in terms of r as a function of radius. Now from here, we know height is 2 radius, right? So it could be written as 1 by 3 pi r square times 2r. So we get the volume expression as a function of radius, right? So it comes as 2 over 3 pi r cube. We need to find rate of change when height is 5, right? So if h equals to 5, in that case r is equal to 5 by 2, which is 2.5, right? So r is equals to 2.5. Is that clear? So once you have written a formula explicitly in terms of radius, we could actually differentiate with respect to time on both sides and find dr dt, right? That's the whole idea. So we have dv dt as equal to 2/3 pi times 3 r square dr dt, correct? Simplify this a bit, rearrange, so we get dr dt is equal to 2 pi r square comes in the denominator, so eliminate 1 over 2 pi r square dv dt. Since we need to find dr dt for r equals to 2.5, let's substitute. So we know dr dt when height equals to 5 or radius is half of that, which is 2.5, is 1 over 2 pi 2.5 square times dv dt is 10. So let's calculate. So we have 10 divided by, within brackets, 2 times pi times 2.5 square equals to, we get 0.2546, right? So the answer is, rate of change is 0.25. We can approximate by, let's say, centimeters per second, right? Height is in centimeters. So I hope the steps are absolutely clear. So any function which involves a cone, what you need to do is write this formula in terms of one variable. So we saw earlier, we wrote the formula in terms of height, this time with respect to radius, and calculated, right? So here is the test question for you. Now I would like you to pause the video, copy the question, solve, and then look into my solve. So let us read the question, write down equations, and solve. Question 4. A conical reservoir is filling with water at a constant rate of 3 meter cube per minute. So as soon as you read this, write down rate of change of volume is 3 meter cube per minute. Reservoir is 3 meter deep and maximum diameter is 8 meters. So what you got here is, let me sketch and show you what we're trying to say, right? So basically it's a cone, right? So we'll just make half of it, a triangle this time. You understand, we are working with cone. So I don't even have to draw three-dimensional figures. We say reservoir is 3 meter deep and has maximum diameter of 8. So this is 8. That means half is 4. And this height is 3 meters deep. Do you get the idea, right? So the ratio of, in this particular case, we say height over the radius is 3 over 4. That is how this statement is related. The reservoir is 3 meter deep and has maximum diameter of 8, means radius of 4. Determine rate at which the depth of water is increasing. So we need to find dh dt when the depth is 2 meters, when height equals to 2 meters. This is what we have to find. So basically, you need volume in terms of height, correct? So rearrange, we get 4 over 3 height equals to radius. And what you know is volume is 1/3 of pi r square h. Replace this r with 4 over 3h. So we get volume as 1/3 of pi 4 over 3h whole square times height. So you get explicitly volume in terms of height. 4 square is 16, 3 square is 9, 9 times 3 is 27. Pi h cube. Does make sense? So at this stage, we have got the volume, correct? So take this exercise as kind of summary of what all we have learned so far. Once you have this formula, then you could differentiate with respect to time on both the sides. So we get dv dt equals to 16 over 27 times pi times 3h square dAh dt, right? Don't forget this part. This is what you need to find. You can simplify this at this stage. That goes 9 times. And then rearrange. So when you rearrange, you get rate of change of height with time equals to 9 over 16 times 1 over pi h square dv dt. Now you should put all the conditions and find the answer. We need to look for rate of change of height with time when height is 2. Right? So we know rest of the things. So it's 9 over 16 times 1 over pi 2 square times rate of change of volume is given to us as 3, right? Times 3. Now use calculator to calculate this answer. That's it. So what we get here is, in the numerator we have 27 and in the denominator we have 4 times 16, right? So 16 times 4, which is 64 pi, right? So let's calculate. So we have 27 divided by, within bracket, 64 times pi, bracket close, equal to, we get 0.134 meters per minute. Now units are very important in any word problem, correct? So we get our answer, and that is the rate of change of height dH dt is 0.134 meters per minute when height is 2 meters, right? So write the whole sentence. That makes sense, right? So I hope with this exercise you learn how to solve rate of change of problems, specifically when we are working with a conical reservoir or conical flask or a cone shaped. Remember, the volume of a cone is 1/3 of pi r square h. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thank you and all the best.